thought today we could have a Saturday night special, so it's Saturday, it's night time, I'm drinking red wine and I'm going to be messing with electricity and machinery. What could possibly go wrong, eh? So what I did today is I went to a farm auction where basically you get to bid on stuff that even the tip won't accept. So I'll show you what we've bought. So what we've got here, it's a very big battery charger, kind of an industrial thing. And if you're wondering what I paid for it, I paid the grand total of £1 for it. It's the kind of thing where they pay you to take it away. So it's in what I would say is awful condition. Let's have a closer look. And what we've got here is kind of a very big battery charger, but it's also a booster, so if your battery's completely flat, in theory this will start your car. And of course the other reason that I bought it is, having tidied up the garage, I actually found a piece of floor that didn't have something on it, and I was starting to feel a bit twitchy, so I thought this would just fit in there. So we've got some fairly meaty, I don't know, let's just call them alligator clips, crocodile clips. Oh, the springs on them feel a bit weak, they're a bit rubbish. So here's a positive lead, and that's definitely seen better days, hasn't it? So it's also been getting hot. I'm guessing that's quite a good sign, that the fact that this is all melted at the bottom, because it means it was actually putting some current out. Okay, we've got some kind of remote control switch. Not exactly sure what the function of that is. I'm sure it maybe just turns the output on or off. I mean, it can't really do anything much more exciting than that. Maybe it turns the boost start current on or something like that. So guessing that plugs in there. Of course, no instructions. Well, maybe we should give this a clean, because I can't actually read anything on it. Unfortunately, it looks like a lot of the markings are worn off here. Does that say minutes, amps? I'm not sure. Oh, whatever it says, I've just rubbed it off. Oh dear. Alright, there's the model number, so it looks like it's a Clark 250, and yeah, unfortunately this foam cleaning spray that I'm using seems to be unfortunately taking the lettering off. That's a bit of a fail for me, isn't it? Ah well, that's what you come to expect from my channel. One cock up after another, I'm afraid. Look in here, we've got a 12 volt connector and we've got a 24 volt connector, so no doubt at some point in the future when I decide to buy a truck, I'll be able to start my truck, won't I? Well, I suppose I've got a truck, haven't I? Oh, there's a little LED hiding there, that's cute. Let's give that clean. Super modern, eh? Red LED. Alright, okay, just revealed another label. It says 240 volts there, and look, that looks like a fuse symbol. And we've got another little pouch down here. Let's see if we've got any freebies in here. Yes, that's not very nice, is it? Yeah. Yeah, something made by Kennedy. We've got a drill, free drill. We've got a free nut and some bolts, and magnet, free stuff. Oh, got a free spanner. Unfortunately it's so corroded, can't make out what that says. Don't know, I'll have to look at that later. Some kind of bronze shell bearing. Don't know what that's off, no idea. Oh, another free spanner. Chrome alloy. Oh, it's a Britool. Again, seen better days, might clean up. What size have we got? 9/16. Okay, that'll be good for the Chevy truck, 9/16. So everything's full of straw in the bottom of here, so I'm guessing this has been kept in a stable. Got some kind of ignition key switch. Oh, we've got some fuses. Oops, 7 amp. Oh, that's a bit of a win. That was worth £1 for them. I think we're coming to the end of the free stuff. Got a bolt, don't think we need that. Got a piece of metal, might just keep that. That says 25 amp, could that be a current shunt? Don't know. So I think you can see the general condition of this is really very poor. As I said earlier, the meter's smashed, switches seem to turn and click. You know, I thought these had a mechanical timer on it, and I thought that was this knob here, but I'm turning it, and there doesn't seem to be a lot of, you know, clicking or timer action going on. So let's give it a twirl. You can see it's all rusty down the front here. Oh, something rattling inside. That's not a good sign. All the paint's hanging off it. Very rusty. Even more rusty on the other side. Okay, got one that doesn't want to play there. I think these are the perfect type of screw to roll away and end up in one of my tyres. So we'll have to keep an eye on these, make sure none of them escape. Ah, these are knackered. The screws are all rusty. I don't mind rusted up screws because maybe it means nobody else has been playing around inside it. Wine break. Let's get a dress off. Well, this just keeps giving, doesn't it? We've scored some more free tools. It's one of those really horrible kind of chintzy plastic, I don't know what you call that, plastic handles, not a screwdriver bit, nut spinner. Socket nut spinner, it's got a socket on it. What socket has it got on it? I think it might be 7mm. Anyway, we won't be keeping that. So I could hear something rattling inside, and it appears that the transformer was sat on some, I don't know, bent brackets. It looks as though they could be, I don't know if they were maybe spot welded to here or something. Maybe they were spot welded. Anyway, they've broken off. Whatever was holding it has broken. So this is the main transformer, and wow, the windings on here are very thick. So the output current from this thing, it must be capable of quite a high output current because the well, these windings are massive. Yeah, all very loose. There's our earth for our transformer. Now I can't see anything burnt on the transformer. I'm not going to put my nose in there, but nothing smells. So assuming that the damp and the wet hasn't got to it, maybe we'll be okay. And this transformer down here, it's got another of those thermal cutouts on it. So again, it seems to have a fair amount of protection on it, this thing. I forget if I mentioned earlier, we've got these large aluminium heat sinks. So these are the rectifiers for the battery charger, because of course it's an AC, it's just a big transformer. So we've got some big stud rectifiers on here. And they've got a thermal cutout on them, so I can see one there, and also the transformer's got another thermal cutout on it here, so it's quite well protected. So that's in our favour. So if somebody tried to do something stupid with it, hopefully it would have protected itself and survived, or you know, that's the hope anyway. But it's definitely broken off its base frame here, so assuming this works, we're going to have to try and fix this. We'll have to bolt it back down again, won't we? So just to let you know, the purpose of today's little teardown, it's not to actually rebuild it and recondition it. I just want to establish the condition of it to see if it's worth restoring. If this transformer is burnt out or damaged, I'm not going to rewind it, it's not worth it. As I say, I paid £1 for this. If we can get it up and running very cheaply, then we're quids in, but I'm certainly not going to spend money on this heap of junk. So just taking a look at the control panel end, we've got, well, I'm not sure what this is actually. I don't know if it's a defunct mechanical timer. I'm not exactly sure. I don't think it's a rheostat. And looking at the marks on it, well, I don't know if I could see the word minute on it before I cleaned it and rubbed it off. So I'm guessing this could be a mechanical timer. I'm not sure. It looks like, again, it's wired in with, I don't know, I think it's wired in with the primary switching. So you can see the way that these battery chargers work. the way that you change the current output from them, effectively you just turn up the voltage for the output for the transformer. I think it's actually the primary which has got multiple taps on it. So what you actually do to increase the current output, you actually increase the output voltage from the transformer. And if you increase the output voltage, your battery will draw more current. So that's what all these big bunch of cables here that are going up to this selector switch. So this selector switch, basically, it just increases the output voltage from the transformer, which will increase the current. And it's wired into a multi-tapped primary, so we've got lots and lots of different primary windings here. And when I turn this, well, you probably can't see what I'm turning, when I operate this switch, it just brings in different configurations of the primary. Look at that, just a thin piece of wire. That's not factory because it's got a yellow crimp on one side and a blue on the other, and a very thin piece of wire joining the two sides together. Now if I'm not very much mistaken, to me that looks like it would fit that current shunt. I said it was a current shunt, let me go and find it. Oh, it's there. Yeah. So here's a piece of metal that just so says, what does it say on it? It says, I think it says 25 amp, although it might say 250, I'm not sure. But that looks as though that should have fitted between there and there. But somebody in their infinite wisdom has decided to replace this 25 amp current shunt. I'm calling it a current shunt. I guess it could be a fuse. I don't know. Is that what does anybody think? Is that a current shunt or is it a fuse? Could be either, couldn't it? Anyway, somebody's decided to take that out. I wonder why they would have done that. So obviously that was designed to fit there. So they've taken out this 25 amp something or other and they've just replaced it with a very thin piece of wire there. That certainly couldn't take 25 amp. So we've got a little control board here that's got a transformer on it, and I'm guessing this is something to do with the remote control function, because the wires, two of the wires go from this little control board, they go up here and they go to that jack plug which is on the front panel. So here's that remote switch, and that obviously just plugs into there because there's nowhere else it can plug. So here's that rotary control I was playing with before that's just got two wires going to it. And I think it's probably a mechanical timer, but normally when you turn these you can hear them ticking, and yeah, this one isn't ticking. In fact, it's not making a noise at all. Yeah, that probably didn't help. So we got some microswitch goodness going on inside, so we turn it and then it clicks off. So this is some kind of mechanical timer, isn't it? But it's I'm afraid it's goosed. I don't think you'll be able to see him, but there's definitely some clockwork going on there. Oops. Okay, so we've popped it out of its cover, and if you kind of tap that, it runs for maybe a couple of beats and then it stops. I mean, it's absolutely filthy inside, it's full of rubbish, so it may be worth trying to give it a clean, but I suspect something's probably been strained inside it. It looks as though there's a little spring in there, and it looks as though the spring is in the fully wound position. I'm guessing that's fully wound, and it doesn't seem to want to unwind. Maybe it's because the mechanism is jammed and that's why it won't unwind. I don't know. Anyway, we might try giving it a clean. Can't really make it any worse, can we? But I think the easiest thing to do is just buy another mechanical timer. At least we know what it is. Well, I've gone ahead and I've just got out my old Clare tester here, and I've got to admit it's been that long since I've used this thing. I can hardly remember how to use it. But, I don't know, we'll plod on regardless. I'm sure we'll figure it out. Now I know that I need to attach this earth test lead, and we need to attach that to a little piece of clean metal, and yeah, that's going to be difficult on here because everything's really rusty. So let's just clean a piece of metal and yeah, put this crocodile clip on. Put it on there. Okay, so we're going to do an insulation test now, and we're going to do that at 500 volts. And it has passed that as well. The main reason I wanted to use the Clare tester is you can actually power the thing up and it'll give us a reading on how much current this piece of equipment's drawing. So the way we do that, we just flick this switch down here, and then this needle here will tell us how much current it's drawing. So I'm going to do that. Well, it's drawing no current, but as well as drawing no current, our little telltale mains indicator isn't lighting up. So it looks like we've got to dig a little bit further and find out what's going on here. I think it's probably these connections I've got disconnected here. I suspect that you need to engage this mechanical timer, and now we've disconnected that, it's open circuit. So I'll tell you what, I am going to go ahead and I'm going to just put some links in there, and I will bring you back when I've done that. Now, to do that job, I think I'm going to use these really horrible crimp pliers. I bet we've all got a pair of these hanging around in the garage, haven't we, or in an old toolbox, and they are totally useless because they don't really crimp properly. You don't know how much force you're putting down, and the blades are actually too thin. They're awful things, but I'm afraid these are all I've got with me today, so they're going to have to do. So these are the two connections that were previously going to the mechanical timer, so let's just link them out. And maybe it'll power up now, who knows? No, still not powering up. I guess we have broken the electrical rule though, thou shalt check fuses. Now I probably should apologise, I didn't give you a good example there of using one of these insulation testers. Oh, there we go, no fuse. So has it got no fusing because it's damaged or for some other reason? Yeah, I didn't give you a very good example of how to test something, because what I should have done is really I should have just measured between the live and the neutral here with an ohm meter, and I should have checked that we could actually see some resistance there, because obviously a piece of equipment like this you should be able to see the transformer, and it's important that the piece of equipment is switched on before you do things like the insulation resistance test, because the fact that this has no fusing would have negated that test. It would have given a false reading. However, perhaps that explains why we found that box of 5 amp fuses inside it. So let's go ahead and put a 5 amp fuse in. And let's now repeat our insulation resistance test. Which also passes. So will it power up this time? No, and it's still not drawing any current. Could be we've got a switch set wrong. Ah. Well, something went bang then. And all the lights have gone out in my house. Better go and sort that out.